you. Yeah. So yeah, question 9 from the practice exam. So practice exam number 9, it tells us we have these 2 different time periods, right? Use the data below to answer the following 2 questions. The data was collected for a first order reaction. So that information right there tells us, okay, I need to use natural log of concentration at time t equals negative KT plus natural log of A at time 0. And then on that graph, they give us the data table and they say, in that data table at 0 seconds and then 8 seconds, I have this concentration of 0.1 and then this concentration of 0.045. Based on that, what is little k, right? The rate constant for the reaction. And so for question 9, right, we would just need to say, I know my concentration's initial at some point in the future. I know the delta t, 8 seconds between those two. I'm going to plug in and find that for rate constant. So at some point in the future, right, my concentration is 0.045. My rate constant, that's my unknown, I don't know. My time, 8 seconds between those. And then my initial concentration is 0.1. So take the natural log of both of those, and I get negative 3.1 equals negative k times 8 plus, I should have written a negative, right? Negative 2.3. We want to solve for k, so I'm just going to add 2.3 across on both sides. And I get about negative 0.797 equals negative k times 8. And there are seconds, right? 8 seconds, I drop that. So at this point, I would do 2 things at once, right? I've got a negative 1 right here in front of k. So I would divide by negative 8 seconds because my rate constant needs to be a positive number. So divide this by negative 8, divide that by negative 8, and I can get my rate constant. Sorry, I'll try to hold this same direction. All right, so divide that by negative 8 seconds, divide that by negative 8 seconds, and I get a rate constant of 0.09967 inverse seconds. It's a first order reaction. Rate constant for a first order reaction should be inverse seconds. And I think that's closest to the choice A. Yeah, choice A is 1.0 e to the negative 1, right? So yeah, we round this up to basically 0.1 for our rate constant for this reaction. So the key here was seeing that in the problem, they told you it was a first order reaction. So immediately we know the equation we need to use. And then we have 2 different time points, 2 different concentrations. So we have time, concentration. I can find the rate constant based on that. We good for question 8? All right, I'll leave. Thank you. All right, that was question 9. Question 10. It's just a continuation, right? We're going to use the same equation. So question number 10 basically said, what's the concentration of A at, 20 seconds into the reaction? Well, previously we just found the rate constant. So now we're just going to find concentration at a new point in time. So my new point in time is, right, I'll write out the equation first. First order, so natural log of concentration at time t, negative KT plus natural log of my initial concentration. So now our unknown is our concentration at time t. We know our rate constant. We just found that on the previous slide. We found that it was 0.1. And we know, right, that's inverse seconds. We know time is 20 seconds. And from the previous slide, from the previous problem, We know our initial concentration is 0.1. We already did that natural log, but I'll just set everything up. And then, right, we just take the natural log of 0.1, add those, multiply the 0.1 and the 20 seconds, add that together to get natural log of concentration time t equals, right, that's a -2, and this is a -2.3. So natural log of concentration at time t equals -4.3. And remember, when we did this in class, right, I gave you the hint that e to the ln of x equals x. So that means e to the natural log of concentration is going to equal, right, my concentration. So e to the -4.3 is going to equal that unknown concentration at 20 seconds into the reaction. So I do that and I get a concentration of about 1.36 times 10 to the -2 molar for the concentration of A, which looks to be pretty close to choice B, right? Choice B is about 1.4 e to the -2 molar at 20 seconds into the reaction. So we should be comfortable with both of those calculations, finding K based on some data points, or given K, finding our new concentration. Yeah.
So you don't distribute that negative to both numbers.
So this negative right here, now we multiply those two together to get -2. We take the natural log of 0.1, that's -2.3. Add those together to get a -4.3. Yeah.
Can you explain again? Is that just taking the natural log of -4.3? Is it just another way to look at it?
So this is the opposite, right? This is to get rid of the natural log. Because at this point, we haven't solved for concentration. At this point, we've solved for the natural log of concentration equals -4.3. And so that's where I gave you this hint, in class, that basically E raised to the natural log of X returns X. It gives you X back. So we have the natural log of concentration. That's what we have right here. Natural log of concentration is -4.3. So if I do that, E raised to the natural log of concentration, that should give me concentration. So E to the -4.3 should give us what was that concentration.
Oh, so it's just e to -4.3, not e to the natural log.
Correct, yeah. Because the natural log of concentration is -4.3, right? All of this is -4.3. So we just plug that in, right, in place of the natural log of concentration. And then if you're not, just to give yourself some more confidence that that works, if you're not sure of that, right, we could take the natural log of 1.36 times 10 to the -2, and that should return -4.3.
Okay.
That should give you this number back, because you're just doing the opposite operation. Yeah, that's a little trick that we had to go over in class when we did first order reactions. Stop that recording.
What is the zero after the equation?
The zero, so we have two different values of A, right? We have A0 and AT. A0 is our concentration at the start of the reaction. I forgot who asked this question. So this is at time 0. This is our initial concentration. A at time t is at some point in the future. For question 9, it was 8 seconds in the future. For this question, it's 20 seconds in the future. So yeah, this will always be our future concentration. This will always be our initial concentration. Here we were solving for the future concentration, but I could give you future concentration, time, rate constant, and say, based on that, what would the initial concentration be in that reaction?
Yeah. Okay.
Yep. Any other questions on this one? All right, stop the recording now.